this particular lecture, we are going to discuss about cascade control in heat exchanger. Heat exchanger is one of the most important and widely used process equipments in any process industry, and controlling the outlet temperature of the heat exchanger is very important for efficient and optimum process control. In this lecture, we are going to discuss how cascade control can be used for achieving that optimum and efficient control. So this is a simple cascade control scheme for a heat exchanger. So in this particular heat exchanger, there are two streams. There is stream 1 and stream 2. The stream 1 temperature, outlet temperature, is measured by a temperature transmitter, and this temperature, basically this is our this temperature is we want to control. We want to control this temperature. This is our control objective, right? So this is our control objective, to control this particular temperature. Now if we use a simple feedback scheme, then what will happen? The TT will measure the temperature at the outlet of the heat exchanger for the stream 1, and it will send the signal to the temperature controller, and there will be some operator who will be providing the set point to the controller, and based on the differential between the PV and SP, the temperature controller will directly signal to this particular valve, and this valve will open and close depending on the increase or decrease of the MV value, the manipulated variable from the temperature controller. And this way the temperature of the stream 1 will be controlled. Now what happens if there is a fluctuation in the flow of the stream 2, right? There might be fluctuation because of some upstream disturbances here. Now if there is no flow transmitter, for the time being we are considering there is no flow transmitter, there is no flow controller here, right? So in that case, if there is a flow fluctuation, there will be obviously change in the temperature, but change of the temperature will take some time for the transmitter to measure the change, or first the actual change in the process will take some time, and then the transmitter need to measure it, and then the signal will go to the controller, and controller will act upon the differential between the PV and SP. And by that time, when this valve, this flow control valve receives the corrected signal, there may be some more changes in the flow, or there has been some less changes in the flow. It may go in both direction. So what will happen ultimately is, due to the late reaction of the controller, there will be overshoot and undershoot of the temperature that we are trying to control, and this may be very inefficient way of controlling, or this may result in bad quality product. It can also may result in some safety issues because of the sudden increase or decrease of the temperature of the stream 1, right? So to avoid such situation, what is done is basically we install another FT, right, in the downstream of the valve to measure the flow in the stream 2. So if there is any disturbances that is causing the stream to flow to change, that will be detected by this flow transmitter, and this flow transmitter will give the signal to a flow controller here, right? So this will be a flow controller, so this will give a signal to it, and the set point, now this particular MV will not be there anymore, right? So this MV will not be there, right? This will not be there. Instead, this MV will give the signal here, right? And this will act as a set point to this particular controller. So this is, if I consider this is PB2, so this will be the set point to the FC, right? So basically MV is equal to SP2 if we consider this second controller. and output of this particular FC will be MV2, and this MV2 will go to this valve, right? So now if there is any fluctuation in the flow in the stream 2, what will happen? It will quickly get captured by this FT, and this FT will then send the signal to the FC. Now there might be no change in the SP2, but due to the change in the PV2, the MV2 will change, and that will correct this particular flow immediately. So this, what will happen in turn is this change in the flow will not be able to disturb this TT much, and this particular temperature will be much more optimally controlled, right? So one thing to note here, so these are, now you can see there are two loops. One is this loop, which is this is your primary loop. This is the temperature you want to control, and there is this secondary loop here, right? This is the secondary loop. Now secondary loop should be faster compared to the primary loop. Otherwise, you will not be able to detect any changes, right? So this flow, as you know, the response of the flow is much more faster compared to the temperature, right? Temperature increase or decrease of the temperature takes time to happen. Compared to that, the flow changes happens much more quickly, right? So that's why flow can be used as a secondary variable here, and the changes in the flow can be quickly adjusted by the secondary controller, right? And this way, the stream way one temperature does not change. And this is the primary benefit of using the cascade controller. Obviously, there will be some increase in the cost because you are adding one more controller and one more transmitter to the loop. But if you calculate the overall savings by optimizing the control, avoiding the safety incidents, and maybe some other issues, this is very small. The cost of the FT and this controller is much smaller. Only thing is we need to take a closer look at the tuning. How to tune this secondary controller is very important. If the tuning is not proper, right, then there will be some problem. Now, the model controller also comes with a feature where even if you have a cascade control, they can bypass the cascade control and they can directly control uh, the valve when required, right? So that may be another case where uh, maybe there is some issue. Suppose there is some issue with the FT itself, right? And FT is not working properly, right? In that case, the modern controller has a feature that you can directly control this valve. Or maybe in some situation, adding a cascade control may not be effective due to that particular situation. Maybe there is no fluctuation in the stream 2. The fluctuation in stream 2 is rarely possible, right? In that case, you can avoid this extra uh, delay in the loop or all these things. So you can avoid them, and the temperature controller can directly control this thing also. So this kind of a arrangement is available for the model controller. Hope your concept about this heat exchanger cascade control got much more clarity. Thank you.